you're probably at this point, you're lulled into a sense of security, which are probably busy thinking that, these things, we can integrate everything, we can find out all the areas under the curves. But actually, it turns out that, the ones we're giving you here, the ones you get in exams, are all quite nice curves to integrate. And you can find the areas quite nicely. You get nice numbers and fractions, and you can do stuff with them. There's many more that it's really difficult to integrate. So it's actually it'll take you so long to try and integrate it. You're worth just going, let's find another way. And there is another way. We can approximate it. So can you see there? Here, obviously I've chosen a nice curve so that you can understand and see what's going on with it all when we do stuff. You're going to think about applying this to a horrible curve, but the principle still stands. I've split that area between 1 and 3, split it into, I guess, two trapeziums. Okay? So just taking a step back, because it's all about trapeziums, are you happy with that being a trapezium? Yeah. Are you happy with that being a trapezium? Okay. That's kind of just an upturned trapezium. Can you remember back at GCSE, even at the beginning of the exam paper, you got a formula for the area of a trapezium?
Oh, okay. Height.
Yeah.
Half.
Okay, height times, so you want it that way, times a half of A. Okay? You call the top, that bit's A, the bottom bit is B, and the height is obviously the height is the height. Okay? That business there, that bit there, what that's all about is you're finding the average of the A and B, the top and bottom. So what you're doing, you're going, okay, hang on a second, let's pretend that it stopped halfway between A and B. You're turning it into a rectangle, aren't you? You're taking that bit there and sticking it in there. Taking that bit there and sticking it in there. Okay? Whichever way you want to think about it, that's your formula for the area of a trapezium. That's what we're now going to use. You're going to apply that lots of times to our curve. So the height on this one is actually there. Okay? So part of our formula that you're going to see today, you're going to choose values for h. Going back to our curves, what's the value of h for each of those trapeziums? 1, because it goes from 1 to 2. So that bit there is 1. H equals 1. Does that make sense? What if we didn't know that? What if it wasn't split up for us? Well, the integral is between 3 and 1. We'll call this bit A. We'll call this bit, sorry, the position, that's A. This one can be B. How many trapeziums we've got? Trapezium, that can be N is 2 in this case, we've got 2 trapeziums. So if you want to work out the height is equal to the difference between them. So B take away A divided by how many trapeziums you want. This can be x0, this can be x1, this can be x2. I want some more trapeziums. No, let's do it with 2, that's fine. Okay, so the value, this value here, this can be y0, because it corresponds to the x0. The height here can be y1, because it corresponds to x1. And the height here can be y2, because it corresponds to x2. The area of that trapezium, what did you say, Emma? You said that we do half a plus b divided by 2. Half, so h, multiplied by a, which is the height of that, which is y0, plus that one, divided by 2. This one will be equal to the height multiplied by a, which in this case is y1, plus b, which is y2, divided by 2. H, y0 plus y1 divided by 2. We're going to add that onto the other one, which is h, y1 plus y2 divided by 2. If you watch the screen now, if you don't watch anything else, watch this bit. That's not particularly accurate at the moment, because we've only got 2 trapeziums. If we make 1 trapezium, you can see it's even less accurate, because we're including this area in between the top trapezium and the curve. If we make more trapeziums, we make it more accurate. We get more trapeziums. The height would become thinner, wouldn't it? Because the number of trapeziums is getting bigger, the height becomes thinner, we're getting smaller and smaller strips. Okay? What will happen with our formula is, say we didn't have 2 trapeziums, say we had, let's go for 3 or 4, we'd have another height multiplied by, well, instead of the next trapezium along, would be y2 plus y3 divided by 2. Shall we do a fourth one, just so you can see the starting pattern? H, y, 3. Let's do 4 trapeziums. So if n is 4 trapeziums, this one would actually be yn. You keep on going until you get to the last one. Divided by 2. Do you really want to be doing all of these separately? No, you don't. I wonder if we can make it a whole lot easier. Yes, we can. Right, let's just do a bit of algebra. Is there anything that's the same in all 4 of the terms? So here's your h coming out as a factor. Can we take anything else out of all 4 terms? Then divide by 2. So let's take that out as a factor. Okay, big square brackets. What have we got here? We've got y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus all the way up to yn. Those brackets. You happy with that line there? Yep. Okay. Do I need the brackets, all these brackets? Or, because this is just a big long addition, isn't it? So we can just add stuff. Hold on. Let's make that. Can we make it easier? H over 2. Don't need brackets. How many y? Have we got one of those? Okay. Y0. How many? We've got 2 of those. And 2 of those. And 2 of those. All the way till the last one. So can we put y0 plus, I'll move it up even, I'll leave a space so we can put something else in there, plus 2 lots of y1, y2, y3, up to the one before the last one, n minus 1, if we've got more than 3. Plus, of course, we've got yn. Close bracket. We said we don't need to do y1 there and include it there. Why don't we just make it a bit easier on ourselves? H divided by 2 multiplied by, add up the 2 end ones and 2 lots of all the other ones. I can't remember it. No, I might be wrong. I'm going for page 8. To work out the integral, it's roughly equal to h divided by 2. Happy with that? There's your end one. So there's, you know, I had square brackets. They've got curly ones. Brackets, brackets. The 2 end ones plus 2 lots of all the other ones added up. Oh look, they've even got where the height is the end one minus the start one divided by how many trapezia you want.